The law of the lever. When a lever is in static equilibrium, so static means still, means not moving, okay? The magnitude of the effort torque equals the magnitude of the load torque. So that means if you had a teeter-totter, let's say this is my little teeter-totter going back and forth, if you just hold still, that's static equilibrium. Here's a picture of a little lever system to lift the motorhome. So let's say you got a flat tire, you put a plank underneath on a little fulcrum, and you push down on this. Well, if you push down on this and this thing raises, but nothing's moving, it just stays there. So you have someone holding this down, just holding it, lifts the motorhome. That's static equilibrium. So what this is telling us is that the torque of the effort, that's you pushing down on the plank, is equal to the torque of the load. Okay, that's what you're lifting. Okay, in this case here, it's a motorhome. So torque is just force times distance is equal to force times distance. And it makes sense because if it's still, that means both sides have to be the same. In this example here, it says a camper wants to mount a trailer on blocks for the winter. One corner of the trailer is lifted by applying an effort force using a 3-meter steel bar. So that's my little planky thing here, my lever. Okay, it's a steel bar, and we know the total distance is 3 meters. Then it says determine the magnitude of the effort force required. So first thing I should always do when I do any physics problem is write down the given information. So I'm looking for force of the effort, and you put a question mark down. When I look at the picture, I know that the whole bar is 3 meters. So the distance between the effort and the fulcrum must be 3 meters minus this little piece here, which is 0.45. So distance of the effort is equal to 3 meters minus 0.45, and that gives me 2.55 meters. Your distances are always to the fulcrum. Your distances are always to the fulcrum. All right. When I look at the picture, I know from the fulcrum to the load is 0.45, so that's the distance of the load is 0.45 meters. And it tells me what the load force is. The load force is 1.8 times 10 to the 3. So force of the load is 1.8 times 10 to the 3 newtons. Well, my formula is basically torque is equal to torque. So torque is force times distance is equal to force times distance. We put effort on one side, load on the other side. I'm trying to get the force of the effort all by itself, so I need to move this D. To do that, I'm simply just going to divide both sides by D. Distance of the effort, distance of the effort. That cancels out. And I'm left with force of the effort is equal to force of the load, distance of the load, divided by distance of the effort. Now all I have to do is just put in my given information. The load force was 1.8 times 10 to the 3. The load distance was 0.45. Distance of the effort was 2.55. When I plug that into my calculator, I get 317.6 newtons.